I'm check on that for you. Most likely not. Most likely be Monday. I just need to. No, we lost some time yesterday, so all right, kind peoples. As you know, the main um announcement is that the test will be on Monday. Fingers crossed. Hopefully, I can get everything done today. Some people have missed a few classes. The way you make up a missed class right here is you have to watch the videos from that class. You got to make the notes and you have to turn those in. I have been recording the classes, so what I did was I think I put in because my other class I put them as announcements. So I think you should see a whole bunch of new announcements now, and they should cover all the topics. And so that way you can go in and you can find whichever section that you missed. And so you can watch those and use those to make up your missed class. All right. Questions there? All right. So before we step out, just take a small step back. What we're working on today is finding a confidence interval. And a confidence interval is simply two numbers with a given probability or confidence level. And the number I'm looking for is going to be between those two values. Yes. Your confidence interval is found by taking the mean of your sample and either add or subtracting your standard, not your standard error, your margin of error. And your margin of error is found by multiplying either Z critical or T critical by your standard error. Yes. Also, I showed you on SALT and also calculator.net how you can have the computers make those calculations for you. Question 10. All right, so we're going to do one more confidence interval. And the last confidence interval we have to look at right here is for when we have a, excuse me, is when we have a setup where there are only two outcomes. So remember a binomial distribution, the basic idea is that there are just two outcomes, one that's considered to be a success and one that's considered to be a failure. Yes? Well, basically, we're going to show you how to create a confidence interval for a proportion. Because in the end, the binomial distribution breaks down to becoming a proportion when we're looking at our averages. Welcome. All right, so quite simply right here, for a proportion, P right here, the mean for the proportion is going to simply be the probability of a success. Okay. So for binomial distribution, remember we had N and P. N was the number of trials and P was the probability of a success. Yes? Well, we simply take that probability of a success to be our estimate for the mean. And then our standard deviation follows this formula that you need to memorize. It is NP divided by N, and that gives us the variance. And we take the square root of that. So that's NP, I mean PQ. It is P times Q, and that gives us, divided by N, that gives us the variance. And then we take the square root, that gives us our standard deviation. All right? Questions there? You guys okay? It's Friday. Normally on Fridays, you guys are, I'm just waiting to get out of here. I got someplace to go. Yeah. No? Oh, all right. That's good. You guys actually want to be here. So again, just continue right here, 7P right here. The key assumption right here is that for us to have normality, basically N must be large enough. But if you recall from the previous two sections, the answer was N had to be larger than 30, correct? Yes? In this section, the size of N is written out differently. The size of N, instead of it simply being N being greater than 30, you have to take a product of N and P, the probability of a success, and N and Q, the probability of a failure. And when you multiply those together, the answer you must get in both circumstances must be greater than 5. All right? So the idea is obviously, if for example, P is 90%, then Q is going to be 10%, correct? Right? If I have a sample size of 30, 30 times the 10% will not give me a number larger than 5, right? And so the idea is this is how they determine that N is large enough. It must pass these two values right here. Once you have this right here, you can assume normality. And once you can assume normality, all of our probabilities, all of our assumptions will hold. So we can then use our what we're about to show you in a second. Questions there? So most of your homework assignment questions on here, that's literally the first thing you're going to see right here, NP and NQ. You have to remember it's always the same number, and that number is 5. All right, so again, a reminder right here, P is the probability of a success. And so in this case right here, it's going to be the proportion of individuals who satisfy a category. The key thing right here is that because it's binomial, there are only two possibilities, correct? Yes. So for example, what proportion of people in here have orange t-shirts, right? You either have an orange t-shirt or you don't. That's the only two possibilities, yes? And so I have 1, 2, maybe 3 people have orange in their shirts. So that's 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's 3 out of 13. That's going to be the P proportion of successes right here. And Q will be 10 out of 13, the other side of the coin. Yes? Now the key thing right here is that your sample proportion is going to simply be R over N. That's going to be the number of successes divided by the number of people in the trial. Right here, that's going to give you your P hat, your estimate for P. Questions there? Is the binomial stuff coming back? Is it coming back to you now? A little bit? Always? N, P, and Q? All right. So your point estimate for P is going to be P hat. Basically, this is the same thing as X bar, your average, right? Because remember, just taking the number of people who say yes, divided by the total number of people. And so then it's your average right here. And then your standard error, your sigma, is going to be the square root of PQ over N. Again, PQ over N is your variance. And when you take the square root of that, that will give us your standard error. All right, questions there? Questions there? All right, cool. And so your confidence interval right here is going to be just like we did a while ago, your critical value multiplied by your standard error. Yes? Remember this previously, the standard error was sigma over the square root of N. But because we're in a binomial situation right here, it is P times Q over divided by N square root N. It's your new formula for your standard error. Okay? Okay. Okay. But the good thing right here is that it's back to Z. And again, to calculate Z right here, we use that in salt. And of course, remember T was for the student T distribution. Z will be for your standard normal distribution. Yes? Yeah. Standard normal distribution. And of course, to find your upper and lower limits for your confidence interval, you simply multiply these two numbers together and then either add or subtract them from your P hat, and that'll give you your lower bound and your upper bound for your confidence interval. Questions there? All right, so let's walk ourselves through an example. Hopefully that will help clarify things. In a survey of 517 music teachers, 403 said that the video games Guitar Hero and a Rock Band have a positive effect on music education. You guys remember Guitar Hero? Construct a 95%. What percentage we need? A 95% confidence interval for the proportion of music teachers who believe that these video games have a positive effect. Round your answers, your lower and upper limits to 3 decimal places. First thing we need to do is check normality, i.e., as our assumptions of NP and NQ greater than 5. And so P is going to represent the probability that a single teacher thinks it has a positive effect, and then Q would be does not have a positive effect. Okay? And thus, P will be 403 divided by 517. 403 out of the 517 teacher says, yes, it has a good effect. Q would be the opposite of that. This right here is what, 78%? So Q is going to be 78 from 100, 22%. And sorry. And so Q will be 22%. Questions there? Now that I have this, I can go ahead and I can test my normality by checking greater than 5. And so you're going to take P hat and multiply it by 515. And then you're going to take Q and multiply by 517. And then we're going to check to see if each answer is greater than 5. The first one is, the second one is greater than 5. And so that means we are in business. All right? If the answers were neither one of them was not greater than 5, then literally you don't have the tools to answer the problem. And so the answer is does not apply. All right. So of course, almost all your assignments, they're going to be greater than 5. All right, so now we've done this right here, we now have to go ahead and we can now apply and find our confidence interval. And so finding our confidence interval means finding the margin of error. We already know P, right? P was 403 divided by 517. So we already know P, so we need to find our margin of error. Our margin of error is based on multiplying your critical value by your standard error. Yes or no, or maybe so? Standard error. Yeah. So another way of writing this right here, your critical value is going to be Z critical, and your standard error is going to be all of this right here, P hat times Q hat divided by N, take the square root of the whole thing. And so we have to do these one at a time. All right, so to find the Z, let me remind you by going into your, let's go into salt. Do I have salt already open? SALT. So you go into salt right here, you click on normal distribution, right? We go back to normal distribution right here. For these right here, we always click between. And we wanted a 95% confidence interval, yes? And so we plug in 0.95 right here. And there it is right here, 1.96. That's going to be my Z critical, my Z star. Questions there? Questions there? And so that's how they come up with the answer of 1.96 right there. Questions? So I now have my Z critical, and this right here is a mathematical calculation, right? Because we already have P and we already have Q. So we already have P hat, we already have Q hat. So we just plug all of them into this really, really fancy equation. You guys like fancy equations? I like fancy equations. So P multiplied by Q divided by N, 517, and you take the square root of that whole thing. That gives me my standard error. And then you multiply it by 1.96. And that gives us our margin of error. Questions there? Questions there? Too bad we don't give you a cheat sheet on the test, yeah? Anywho, and so that gives an answer of about 4%, 0.03. 0.04, round into one decimal place, two decimal places. And then you simply take your P and you add and subtract, and that gives us our confidence. And in other words, we are 95% confident that the true mean for the number of teachers who think that a band, hero, and rock band have positive effect on students are between 74% and 82%. Questions there? Comments? Queries? Concerns? All right, let us show you how to find these two numbers right here using our good friend SALT. Let's find our answer using our good friend SALT. So the nice thing about SALT right here for these things right here is that SALT has simplified it quite a bit. What we need right here again is inferential statistics. So you come over to inferential statistics. It looks like this right here. And this time you're going to need one sample P. One sample proportion is what you're going to need right here. One sample proportion is what you're going to need. The nice thing about this interface right here, let me click on confidence intervals because that's what we're doing right here. The nice thing about this thing right here is you only need 3 numbers instead of 4. The first right here is the number of successes. I think it was 407 teachers who thought that it was great. 403. 403 out of a total of 517. Yes? And then you just put in your confidence interval, in this case, 95%. And then that's all there is that's all there is to finding your confidence interval. The number of successes total, because what happened is, okay, let me do it again then. So yeah, let me go back. So first things first, this way it starts with one sample T. You click right here on one sample proportion, and then you fill in the number of successes and the number of trials. All right. So again, it can find Q, right? Because Q is P minus 1, yes? So if I divide these two numbers, it'll give us P hat, yes? If I divide these two numbers, it'll give us P hat, and it'll go on to find Q hat. So it can do everything with just these two numbers, and you got to tell it how confident you want it to be. So because of that, you only need 3 numbers. Okay, hit generate results. And here you have right here your answer. This is your lower limit, and this is your upper limit. If you want to round to 3 decimal places, 0.815 and 0.744. It will also give you P hat. Again, remember P hat was 78%. So therefore Q was 22%. It gave us the standard error right here. The standard error was the square root of P hat over N. But that's all there is to it. You have your confidence interval for your proposal. Questions there? And that's it. We gotta do the letter N. But other than that, that's it for the section right here. Question. All right, cool. So where am I? I think it's this one. All right, so like I said, the show you how to do it on a graphing calculator. And then show you how to do it in Zoom. Sorry, in SALT. Go to your inferential statistics. Plug in your 3 numbers, 1, 2, 3. Hit generate results. Hit generate results. I'm hitting the button. Nothing's happening. I'm hitting the button. Nothing's happening. I'm hitting the button. Nothing's happening. And then there you go. It will then give you the result. Questions there? All right. P hat. We went over all of this good stuff. All right, and so This right here is kind of an overview of the chapter right here to kind of give you an idea of what's going on right here. It's a nice little overview right here. So 7.1 sigma is known. In 7.2, sigma is unknown, and in 7.3, it's binomial proportions, right? Those are your three sections. For each of them, you're making a confidence interval. Yes? The confidence interval is always taking a number and multiplying it by your margin of error. Okay? Notice for 7.1 and 7.3, you're using Z, right? But for 7.2, you're using T, critical. Does that make sense? Right? For for each of them, excuse me, excuse me. For each of them, your standard error is slightly different. 7.1, it's sigma over n. 7.2, sigma is unknown, so it's S over n. And then 7.3, it's P times Q over n. The last two can be done in salt to create the your confidence interval. For the first one, you have to use the calculator.net that we gave you. Questions there? Find all of the Z's and T's. You can do all of them in salt, right? You use the T distribution for salt, and for the other two, use the Z distribution. I just showed you how to do it a second ago. Remember, for the T distribution, you also need to know the number of degrees. You also need the degrees of freedom, which is equal to n minus 1. Anybody, any questions there? So each of them are slightly different. Last thing to mention right here, your x bar. Remember this last one right here, your x bar for your binomial is actually a p, a proportion. Okay. Questions there? Number of successes divided by the total number of trials. Questions there? All right, cool. All right, so like I said, last thing is your letter N, sample size. All right, suppose we want to specify the maximal margin of error in advance of our confidence interval for P. We need to then calculate the sample size, just like we did in 7.1. Yes, just like we did, we need to have a formula for calculating the sample size. Well, it turns out in this section, there are two methods, depending on whether or not we know the probability of P, or we have some information on P beforehand. If we do not have a preliminary estimate for P, we always use P equals 0.5 and thus Q equals 0.5. This will guarantee the largest possible confidence interval. Okay? If we have it, then we just use it. But here we go. We do the math. The error is equals to Z critical multiplied by the standard error. If you solve for N, you get this formula right here. If you recall, for the other one, the formula was different. It was E times sigma over N. No, not over N. Over Z star. My bad. Z star times sigma over E. The formula right here squared. This formula is different. The only thing that remains the same is the round up always stays the same. Remember when you did this right here, you had to round up no matter what when you get the value of N. Yeah. And so that's how you get this value right here. And the thing is this right here. If you do not have a preliminary estimate, you use 0.25 times a Z over E squared. If you do have a preliminary estimate, you use PQ times a Z over E squared. Of course, always round up and double check to see if your sample size is large enough. If your sample size is not large enough, you just get the smallest value for N such that these two things are true. Questions there on the formula? Questions there on the formula? Again, you don't get a cheat sheet, so you poor things. Oh. All right, example. A company is in the business of selling wholesale popcorn to grocery stores. The company buys direct from farmers. Yay. A buyer for a company is examining a large amount of corn from a certain farmer. Before the purchase is made, the buyer wants to estimate P, the probability that a kernel will pop. Pop. Suppose a random sample of n kernels is taken, and out of these kernels pop. So they took a random sample, threw it in the machine, pop, pop, pop. Guys don't like popcorn? I can eat popcorn all day, all night. The buyers want to be 97% sure that the point estimate P will only have an error of no more than 0.01. So they're giving us the confidence level, 97%. They're giving us E, 0.1. And so we just need one more number, P hat, Q hat, to kind of figure out the size of N. They're going to split it up into two scenarios. A, if no preliminary study is made on the estimate of P, how many kernels should they use? In this case right here, when there's no preliminary study, you use 0.25. In other words, P is 0.5 and Q is 0.5. When you multiply them together, you get 0.25, right? A half times a half is a quarter. Yes. And then you're going to plug in your Z star and your E and square it. Now give us our answer. E is 0.01 and a Z star for 0.97. Do you guys want me to show you how to find the Z star in salt one more time? How you guys think you got it? All right. So let's go back to salt right here. In salt, you go to a distribution calculator. It's a Z star, so you leave it as normal distribution in between. And in here, you just put your 97% in salt. All right. So divide, blah, 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 and enter. And the answer is 2.1701. That's going to be your Z star or Z critical. Head on back. And so, blah, 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 blah. See, they got the same answer we got, 2.17. Questions there? So you plug those in, 2.17 here, plug in 0.1 E right here, square them, and then multiply them by 0.25, and you get an answer of 11,773, because you always round up. You always round up. And so this is the number of kernels they'll need to test. So they'll have to buy a whole bunch of them, pop them, and then see what average number of kernels pop. All right? So the buyer will need a minimum sample of a whole bunch of kernels, 11,773 kernels, to meet the standard that they require. Questions there? Now, of course, they skip the NP and NQ greater than 5 because 11,000 is so huge. They skipped NP greater than 5 and then NQ greater than 5. They skipped that right here because this number is so huge. If you multiply them by 0.5 and multiply it by 0.5, that's going to be much larger than 5. Yes? So that's why I didn't mention it. But in theory, you should check to see if these are greater than 5. Question there. And a part B right here. Let's say we've been buying corn for popcorn for a while, and we know that normally about 86% of them pop. Yeah? And so let's go ahead and find N again, but with this number in mind. So the formula is going to be P hat times Q hat. Again, which is the same 97%, so the same 2.17. And of course, 86% and 14%. Yes, 1 minus 0.86, 14%. So you multiply all of this together on your handy dandy calculator, and it gives us 5669. And of course, we're going to be rounding. And so it's going to be 5670. And notice right here, if we have a preliminary estimate, the number you need is much smaller. Because a while ago it was 11,000, yes? Right? If you have a preliminary estimate, your answer and we are much smaller. Question there. The preliminary estimate, the 0.25, that'll always give you the largest possible size for n. If you have any kind of estimate, that will make the answer small, make the number n you need to be smaller. Again, last thing right here, didn't put it in here, but you do need to check, see that NP and NQ, you multiply them together, the answer is larger than 5. If the answer is not larger than 5, you got to find the number n that makes it at least 5. So you need to increase n until these two things are satisfied, and that would be your actual minimum. All right. All right, so that's it. We're done at 7.3. Your test is on Monday. Not March 22. This is an old slide. The test will be on Monday. You guys got 3 days to live. For all those who are still in the running for America's Next, all those who are still in the running to get an A and just get excused from the final exam. Remember that on Canvas, there you can do what's called what if analysis. You can go into the grade book and you can type and say, what if I get a grade of 80 on test 5 and I get a grade of 88 on test 6, and it'll adjust your grade and show you what your grade will be. Yeah. If you are missing homework assignments, you can let me know. I can reopen those for you so you can get those done. But basically, after test 5, we just have 2 more assignments left. That is the test 6 and the final exam. All right. So you'll be getting down to brass tacks pretty soon as they say. Any questions? Oh, I need to fix that assignment, don't I? I'll do it now. It's going to be due on Monday. I'll push everything back to Monday. All right. But other than that, you guys have a nice day. Oh, let me take attendance.